Our next speaker is already on the stage, so go ahead, Ben.
Yes, thank you. I'm going to sit down because I feel like I'm getting a flu. I got the flu vaccination, but you know, I have kids and can't escape it, so I'll try my best. No, it's going to be great. Yeah, I try and be a bit relaxed about this. Like, it's always a bit difficult to judge what kind of things you should put up when you're doing public speaking, and it's not an academic situation. So that said, then they came and asked me to talk about my career. And I said, career? I can barely know her. No, nobody gets that. And when the laughter died down, then I thought, what exactly involved in my career? At the moment, the gist of my work is about high-performance cognition, which is a state when you are doing a demanding task with high skill and performing very well. It's engaging and it's all-encompassing. It would be the top left quadrant of Jana's picture of attention, but it would be typically self-motivated or self-motivating. It would be the typical kind of task where people dedicate a lot of their time and energy to it and become experts and so on. So like music, race driving, and computer games is what I've chosen to study. So that's the most experimentally feasible, tractable type of program that I could find. I work in the cognitive science unit with docent Otto Lappi, and he likes to study race driving, and so it's a similar thing applied to a different domain. It may sound a bit like the theory of flow, which is a psychological theory dating back 40-odd years or more, but it is an attempt to move beyond or to move laterally to that psychological theory of flow, and to bring in neurocognitive data and neurocognitive observations and to build a theory around that. So today, apropos of doing this kind of public talk and with respect to my career, and try to do it in 15 minutes, I thought I would just discuss a little bit about the theory that I have in mind, and that's still a work in progress. So where does it come from? I'm a computer scientist by training. And when I was doing my undergraduate, now 20 years ago, so I was reading this book, The Emperor's New Mind by Penrose. And The Emperor's New Mind is about, it's a rebuttal to the concept of strong AI. And strong AI is the hypothesis that intelligence can be algorithmic. Intelligence can be generated by an algorithm which is computationally tractable, and you can then create truly intelligent beings via a computer. Penrose, at the time of writing this, thought that he disagreed. I don't know what he thinks now, but anyway, that's neither here nor there. But he disagreed, and he did so on the basis that the products of human thought, especially mathematical, are often embodied or characterized by this non-computability, this decidability paradox. So within the framework of the rules which you set for yourself, there are problems which you cannot decide the answer to, you cannot compute. This was the result. I mean, this proposition of decidability dates back to Hilbert at the turn of the last century, so 1900s, or 1900 something. And yeah, the classic mathematical result of the Turing machine is an answer to this decidability problem. And Penrose's hypothesis was that we simply cannot encapsulate the observed products of the human mind within this kind of a machine, mathematical machine. Which isn't to say that you couldn't do it with something that we haven't conceived of yet, a computer that we haven't conceived of, or a computer like a quantum machine that we haven't built yet, but that we're working on. So that's why I say I don't know what Penrose thinks about this now anymore, but that's not the point. But again, the debate about strong AI was not my main takeaway, or was not my main inspiration. I didn't end up working on that. I ended up working on human cognition. And the reason why I mentioned this as my inspiration was because it was these products of human cognition that I found to be inspiring. How are individuals capable of, and why do they produce these higher cognitive capacities, this kind of intuitive cognition? And when I try to justify this kind of concept to myself, I often go to this metaphor of the tree. I'm not having a lot of debates about these kind of things scientifically. I'm just kind of have this in the back of my mind while I do more practical work, but I'll get onto that now. But yeah, the metaphor of the tree is this idea that we could be, we may have this cognitive capacity for this intuitive thinking due to the aesthetic, due to our capacity for aesthetic reasoning, based on recognition of the goodness of the environment around us. So it would be an ecological argument that the environment around us, including trees, generate themselves to a pattern which has some degree of goodness, and it has an ecological reason for being. The tree grows into a kind of beautiful shape like this in order to fill an ecological niche and to obtain as much energy as possible from its environment. That's what an ecological niche is. And we recognize the beauty in that, and there has to be a reason for our recognition of the beauty in that, and it could be that these things are related. But as I said, I don't work on this stuff. This would be more philosophy, and I work on more practical things. And I had to take these inspirations and apply them somehow. So what I decided to do was, as a computer scientist, it was easy enough to access the world of video games as a domain of study. And in this theory of flow was a pre-existing theory that I could kind of latch onto because it related quite well to my ideas. So I started off with this in my PhD. It's a reasonably popular article presenting a theoretical account of why flow occurs in video games and what it means. And it's an account that's based on the information processing that happens in video games. Unbeknownst to me at the time, this is a perfectly cognitive perspective on the problem. I was in a computer science lab. I didn't have cognitive science professor, so that's why I say unbeknownst to me. But it turns out that it works out quite nicely. And so in later years, then I have become more or less a cognitive scientist somehow. But first of all, like let's unpack this a little bit. What have I said so far about how high performance cognition relates to flow and what it therefore might be? So flow, first of all, is this state of high performance where you're doing this demanding task with high skill, and it generates this kind of psychological experiences, which is the kind of psychological part of the theory. Some of those are more relevant to me, some of them are less relevant, but the core of it is expressed in this channel model of flow, which dates back to 1975, the first paper by Csikszentmihalyi. There a laser? No laser? Oh, there's this. This is cool. Wow. That's something else. This is the spotlight of attention. Yes, excellent. So that's Csikszentmihalyi's first paper on the topic, and where he described flow as occurring in a balance between challenges and skills. And outside of this balance, you would have different psychological states depending on which direction you're going in. If your skills are less than the... yes. Boy, it's a bit slow. If your skills are less than the challenges, then you might feel worry, and vice versa, you might feel boredom. And outside of the kind of balance by a long way in either direction, you might feel anxiety, which would come from different sources, either the anxiety of performance pressure or the anxiety of being stuck in a task that's really trivial and you want to get away from it. And later on, then I'll just skip over these things quite fast, but this flow channel was then reconceived into a quadrant where there's a kind of reference level there, which has to do with the fact that there was this hypothesis that flow wouldn't be occurring when your challenges or your skills were too low levels. When the balance between them was too low, that would be just apathy, not really flow. And then there's the octant model, which is just another iteration of the same thing with more labels on it. And we've, by the way, done some work on showing how these models are a bit underspecified. And then comes the interesting part, because for me the interesting part, because this flow state, and it is a state, has to also relate to the temporal perspective. So what happens over time? This is part of my original 2008 paper, but what happens over time as you're in this flow channel, you are learning the domain in which you're acting. You're learning that domain and it becomes less novel. So therefore the challenges will go down. And as you learn, if you're here, well, this is Csikszentmihalyi's picture, but yeah, if you're in balance and the challenges go down, then your skills will exceed the challenges and you'll move out of the picture. Then you may want to engage yourself with more challenge, i.e. tackle more novel situations and go back up again. Csikszentmihalyi's annotation here, these A's, have to do with the kind of converse reasoning, whereby if you're in AYX, you're maybe in a excessively challenging situation, then you have two ways to go. You can either increase your skills and move to AYY, or you can decrease the challenges. And he was talking about chess players who would be playing another chess master, and therefore they could either choose to play somebody at a lower skill level, or they could go away and train and come back again and be playing the same person, but now their skill level would have increased. We have to conceive of how these processes play out in a cognitive system. So we need a kind of a theory about how skill develops. And luckily there's this expert performance theory by Ericsson, which says that, well, for an ordinary person, you start tackling some task and your performance is initially low, but as you learn it a little bit, then your performance raises. But then if you just continue to do it in a kind of ordinary way, just repeating and repeating, you sort of hit some plateau and you tail off, and that would be an experienced person. How you get to be an expert then, in expert performance theory, is that you do deliberate practice, which is where you challenge yourself to take on fresh novelty and master it, and then your performance keeps rising and rising until you get to some plateau point which is undefined. We may conceive of this kind of rise to expertise. I mean, first of all, we can say that expertise can be defined without being really necessary to define it in reference to a global expertise. We can define it in reference to the task itself. So you don't have to be Lewis Hamilton to be an expert. You can just be a good race driver in your own local domain, or you can be a good kart driver. You don't have to be winning World Series of esports to be good at a computer game. You can just be good enough to kind of beat the game. And in that sense, then you have some level of expertise in the game. Whichever way you define the expertise, though, there is a sort of fractality to this curve of... I can't do that backwards. I wanted to do it backwards. There's a fractality to this curve there, where the deliberate practice gets you to a certain point, but then you know from your own experience that you can't be putting that much kind of cognitive strain on yourself on a constant basis. You kind of hit these plateau points, and then you go along for a while, and your training goes on, and you kind of begin to get used to where you are, and then you start to kind of rise again. Your skill either starts to increase, if you're training kind of in the right way, either increases by itself, or you have some kind of a mental breakthrough and you realize how you're going to push yourself forward. Either way, though, there's this kind of fractal pattern, and we can kind of look into that particular pattern and characterize it as the cycling between exploration, which I would call this deliberate practice kind of thing as exploration, and exploitation of those skills. So you explore the domain, and you get to a certain level of capability, and then you sort of have to make that, you have to sort of bake that into yourself. You have to make it intrinsic. And it comes back again to the flow channel model, or the flow octant model in this case, where if this is high performance cognition in this cycle, pushing yourself forward and then sort of plateauing and like reaching an internal mastery of the skills you've just pushed, and then repeating, then we can fit that high performance cognition into that picture of flow, and that becomes our sort of instantaneous model of high performance cognition. So that's like the kind of high level cognitive theory of HPC at this time, is that this is an instantaneous picture of high performance cognition. It fits the flow model, but it doesn't go inside the flow model. It kind of puts the flow model inside of it. And then this is the kind of temporally extensive picture. Right, so that's one perspective on high performance cognition. I haven't gone into the sort of neural theory details yet, but yeah, this is another way of looking at a different picture drawn by Otto. So just in case the other one is more confusing, this is, or whichever way you want to look at it, this is the same thing but drawn a different way. It's coming to a close. Can you roll the video, please? So what we've been doing recently is sort of testing this flow model. There's Otto, if you can see him. He's in the screen, reflected in the screen. He's driving this excellent flow generating game that we have. And we did an experiment on this, and we're doing another one now. And you can come and talk to me if you're interested in actually participating in this experiment. But yeah, the idea is that the game generates flow by always putting you in a position where skills match challenges, and it serves as a kind of useful probe into this theoretical realm, and it's another level then to sort of move that theory beyond the background frameworks of flow and expert performance, and sort of develop the high-performance cognition theory itself, but one step at a time. So I just want to now thank the team that did this flow experiment and yourselves for listening. And if anybody has any questions, please shoot. Well, either way, thank you very much.